Welcome back. Today we're going to talk about numbers. I know some people don't like numbers. I do. Numbers are the reason I don't get ripped off. Well, sorry, I got a little bitter there. But the bottom line is, in order to prove these concepts and theories of the field of chemistry, we need to be able to do measurements, which means we need units of measurement, and we need to express those units in numbers which are base 10 in nature. So the SI system is what we're going to talk about, and the SI system is base 10. Unlike Old English units where a cup is 8 ounces. Okay, quarts 32 ounces, gallons 4 quarts. It's not consistent, but the SI system is. So let's talk SI system of measurements right now. Aloha everyone, aloha, Mike here. Today we're going to talk about big and small numbers, powers of 10, and the SI system of units, and at the end we'll convert between those units. So, but first I'm going to shoot you a number. I'm going to say, hey, look at that number. And that number right there, that is the mass of a proton. And maybe you're not really familiar with what a gram is or what a gram looks like. And frankly, if you ask someone on the street, they might not know what a gram... Oh, well, actually, if you ask someone on the street, they might know what a gram is, if you know what I mean. But a gram's about a paper clip. Trust me on that if you need to ever visualize that. So then we'd say, hey, that's the mass of a proton. And you'd say, whoa, Mike, dude, that is really small. And see, there's times when we have to give you the context of how big or small something is, and then sometimes that's just clumsy. So what we'll do is we'll say, hey, we're going to just come up with another unit. We'll say about what a proton weighs is an AMU. But you see, I could have told you that from the get-go, and you wouldn't have the context of how small a proton is in mass. So you would probably agree with me that that top number is super clumsy. But if I write it in what we call scientific notation, it actually takes up a lot less space and is a much more concise way of describing to you that. So that would be 1.67 times 10 to the minus 27. And the way you write scientific notation is you have a partial power of 10 times the power of 10. Okay, look, you don't have to really have wrapped your brain around that yet. Let's just talk about powers of 10. So let's talk about what 10 to the 2 is. So that power in superscript, that just means 10 times 10. That's why it's 2. So 2 times, you've multiplied 10 times itself, and you'd see that that is 100. And if you had 10 to the 3, that would be 10 times 10 times 10, and that would be 1,000. Now, these zeros start piling up pretty quick, folks, when you get into this field of chemistry, because things are so big or so small. Like the mass of a proton is very small. The number of atoms in 10 grams of stuff is very big. And so we're going to really run into problems if we start just rattling off zeros. And some people try to fight it. They try to fight it. They're like, I don't like scientific notation. I'm going to fight it. But trust me, it's going to be a losing battle, or it's going to be painful. So you got to warm up to scientific notation. So let's talk about what will happen if I divided 10 to the 3 by 10 to the 2. So we're going to talk about operations on numbers with powers of 10. And if you just take those numbers from above, you'd say that's 1,000 divided by 100. That should be 10. But the thing to do is you could say, when I divide powers of 10, it's really simple. They subtract, because 10 to the 1 is just 10. And so keep that in mind, that, you know, when you divide or multiply, they either subtract when you divide, or if I were to take 10 to the 3, which is 1,000, and multiply it by 10 to the 2, the powers just add. That's 10 to the 5. What's 10 to the 5? Well, it's the same thing as 1,000 times 100. That would be 100,000. So keep that in mind, because if we can get things in scientific notation, sometimes the math is a lot easier. All right? So let's talk about how you express something in scientific notation. So at first I'll take a very small number, but not as obnoxiously small as the one in the example above. I'll go ahead and say, 0.00045. Now, the way you would convert that to scientific notation is you would move the decimal place either left or right, and I don't want you to memorize left or right because I get that backwards all the time. You move it whatever direction you need to go to get to a partial power of 10, which means you're between 1 and 10. So, got to keep track. 1, 2, 3, 4. So that would be same as 4.5, because I moved the decimal point there, times 10. Now you got to just understand that when it's, as in the example above, if you had something that was a small number and it's less than 1, then the power of 10 is going to be negative. Okay, don't worry about left and right. You moved it to the right, and just don't memorize that because you get it backwards. When it's a small number, scientific notation is going to be to the negative power of 10. What did I do? 4? I forgot what I did. 1, 2, 3, 4. That would be 4.5 times 10 to the minus 4. So let's take some big, huge number. 125. I won't put commas in there. I want to get away from that. I don't need. No, let's put the commas in there. All right. And then I've got to move the decimal point from there to 1, 2, 3, 4, 5, 6, 7, 8. All right? So that would be 1.25 times 10 to the positive 8. And you know what happens, folks? At some point in time, you actually kind of get used to thinking this way. So you end up remembering your landmarks. We do these things in threes. So, when you remember that 10 to the 3 is 1,000, and 10 to the 6 is a million, and 10 to the 9 is a billion, and then 10 to the 12 is a trillion. And after that, actually things lose context because even the national debt isn't much bigger than in the trillions. But, if you're a computer person, you have to deal with this all the time with mega, giga, all that kind of thing. Now, I'm going to try to narrow our focus today on the units that are powers of 10 based, that are metric, and they have little prefixes. But before we do that, let's talk about how your calculator is going to be your friend, and let's do some calculations in scientific notation just next. All right, so let's say we wanted to do that calculation right there. And now what I want you to do is not panic here. What you're going to do is you're going to see that there's two parts to the numbers. Now, when we talked about before, when these powers of 10 are divided, the powers of 10 subtract from each other. So whatever we're going to get as a result, I'll put a little space there. It's going to be a times 10 to the 5 minus 2, 3. And then the other two numbers just divide like they normally would. So this would be 4.68 divided by 3.21. And then I'd have to, I'm going to be consistent. We'll talk about digits another day, how do we be consistent. But you could see where this had 3 digits, that had 3 digits. So we'll express this in 3 digits. And the answer to that would be 1.46 times 10 to the minus 3. All right, let's do another one. Let's say we were going to multiply two numbers, and we were going to try to express that. Let's multiply these two numbers. 4.68 times 10 to the 5. And we were going to multiply them by each other, times each other, 3.21 times 10 to the 2. And we want to say, what's that product going to be? Same procedure, except now the result will be times 10 to the, now these add 10 to the 7. Now, when you get better at this, you'll be able to say, well, I'm multiplying two big numbers. I'm going to get a bigger number. So that's the way to keep yourself honest, right? Here, you divided a bigger number by a smaller number, and you still got a number bigger than 1. But you would be able to say, hey, you know, that's like 10,000 or 100,000, 468,000, and this is 321. You'd start saying, well, I'm just going to get a bigger number as a result. But I'm going to take the 4.68 and I'm going to multiply it times 3.21. And I would get 15.0. Now that presents a problem. And you realize that 4.6 times 3.2, that would give you 3.0. And now what you got to do is, the etiquette of scientific notation is that you should be writing a partial power of 10. That's greater than 10 to the 115 is. So you would move the decimal point here. And this is where I'm telling you, you get good at it. This would be 1.50. But that didn't come for free. I had to either give back or take away from the power of 10. Now think about it. What would be the right thing to do? I had to make that 10 times smaller, so that would have to be 10 times bigger. And that would be your answer. Now, I don't want to condemn calculators. They're great tools, but I'll show you how we use mine. I'm going to do that same calculation, and I have had some of my students before get mixed up this way. So let me make sure I got those numbers. This is a $10 calculator, folks. Your friend Mike, he doesn't have much class, doesn't need much class, but you're going to need something of this nature and not trust blindly in it. It's great to use it, but we won't want to be trusting blindly in our calculator. But the way you do this, that same calculation, 4.68 times 10 to the minus 5, I just type in 4.68. Every calculator will have some form of exponent button. Don't hit the times and then times 10 to the whatever, because sometimes people do that and then for some weird reason you get an extra power of 10 in there. You hit that exponent and you will notice on my calculator it kind of goes and has a power of 10 there. Actually what it does is, some calculators, the ones that are better, will say times 10 to the, so you can see that. So I'm going to go ahead and type in 5. That's 4.68 times 10 to the 5. And then I'm going to say times 3.21. Hit the exponent button. Times 10 to the 2. And there you go. 1.5. Now, okay. Good. I'm glad this came up. Sometimes if the number is not very, very big or small, it'll default into regular notation. But I can hit this second button and then hit the psi function, and it'll then switch it to scientific notation for you. And you can see, I hope you can see, that that's 1.50. I will talk about how we round digits later on another day, but you see times 10 to the 8th. So, you know, you can do it by hand with a really clunky calculator, but when you start doing a bunch of calculations, it's a lot easier to be able to put that in there in your calculator, and then not trust it completely. You want to say, does that number make sense? Like if I typed that in wrong, I could say, let's say I put that in there wrong as a -2 or something. I realized that that number should have grown when I multiplied the two times each other. And so there you go. That's the thing. Next, let's hang that up a little bit for now. I'm going to talk about unit conversions at the end today and the next time as well. So we're going to be crunching numbers for the next couple days, but we will get to the good juicy stuff as to like why things explode and all that kind of stuff that really is you're looking forward to. But this is our toolbox, and our toolbox involves numbers. And as I said in the beginning, and we're going to talk about it tomorrow, if you're going to buy a car, if you're going to build a bridge, you're going to dose a person with some medicine, you need to crunch numbers, and you need to do it reliably and in a hurry and accurately. So that's why we're doing this as we embark upon your lab journey and others. So next, let's talk about units real quick. Heyo, we're back. Now, I want to talk to you about how we as Americans are wonderful and everything, but we have been slow to adopt the Système International, which is the international system for measuring things. Now you notice that some of this creeps into your life a little bit. If you take an aspirin, you'll notice that, hey, that's 324 milligrams, right? And milli means something, but the nice thing about this system is you can plug anything in front of any kind of unit. I can say millimeters, I can say milligrams, I can say milliliters. I can't say milladegrees Celsius. So actually, let's get rid of temperature and talk about that another day. Maybe we'll talk about it at the end of today. We'll see how we're doing on time. But this is what you're dealing with. By the way, they have little symbols. I put grams at the end of that number. You know, little m is meters. That's supposed to be a L. But also you'll see the squiggly L like that, or see capital letter. Now, I want to mention that, you know, some of this, of course, has crept into your life already. You know what a 2-liter bottle is. You know what a meter is if you run track or whatnot. And but the great thing about it is if you compare it to the other, let's take mass. Let's take volume as a great example, and I kind of alluded to this earlier. You know, if we do the old units, like a cup is 8 ounces, and then there's 8 cups, there's 4 cups in a quart, and there's 2 cups in a pint, and it's just there's no consistency. But you could take a milliliter, and you would know, hey, that's a thousandth, as it turns out, of a liter. And so what we have is the ability to use these common multipliers. And this is where I'm going to, although I'm not a very memory-oriented person, I'm going to ask you to tattoo these into your mind, because they will come up over and over and over again. And so let's go from big to small. So we won't go bigger than kilo. Trust me, folks, in lab, you're not going to be handling kilograms of anything, but you might be familiar with kilograms. So a kilo anything, or a kilometer. And I'm going to, remember, powers of 10. You'd say, hey, that's 1,000. Yeah, we're going to call it powers of 10, 10 to the 3. And that's because some of these are going to get really small. As a matter of fact, let's go below 1, because we do these in 3s when they get big, but then there's other kinds of times when we don't. Like, so a deci is a tenth of something. That's 10 to the minus 1. All right? Centa, 10 to the minus 2. Now, you know that means 0.001, or excuse me, 0.01. I forgot where I was. But we're gonna try to harp on powers of 10 here. Milli, 10 to the minus 3. Now here's where things get a little bit weird when we're talking about the size of atoms and stuff. Now we tend to go in 3s, powers of 3. So you know that, you know, above kilo there's like, especially in computers, you know, there's mega, and then there's kilo, and then there's mega, and then there's giga. Well, now we're going into small, so micro. Oh, darn it, guys, I forgot the symbol. So symbol is K, deci, D, centa, C, milli, M. Micro has a weird symbol. That's what triggered my memory. It is a mu. And then let's go all the way up to nano. You know, some people say, hey, it took me a nanosecond, and they joke, but they really don't know what a nano anything is sometimes. But then that's little n. Let's go one further to pico. That should get us through this whole course. So, for example, you want to talk about a wavelength of light. You got to say it in nanometers, because it's too clumsy to express it in meters. If you want to talk about the radius of an atom, it's easier to do it in picometers, because they're so small. So now, folks, let's go and sort of talk about the first thing where we're going to talk about unit conversion. So we're going to convert from other units to other units. So, and this is what we call, by the way, dimensional. And I'm going to talk about dimensional analysis next time as well, because it's just too darn powerful. And it's going to help you in your life. I really mean that. It's going to help you solve. You're going to feel so powerful. Now, first of all, what I want you to do is change your mindset. In this course, there are no plain old just numbers that are just numbers. Everything has a unit, and I want you to think of that as being intimately attached to something. Let's even do with the old English units. I got 145 inches, and I want to convert it to feet. Everybody knows how many inches are in a foot, right? And so you can say, I got to divide by 12. But you know, sometimes people will multiply by 12. They'll do the wrong thing by the right number. And so the way you got to think of this is that inches is that inches is attached to that number. That is a tag that does not get omitted. I know we do it in regular life. You say, hey, I weighed myself. I weigh 165. And we don't say what. And we say, I got pulled over. I was going 80. And we don't say it's miles per hour. But you know what I like to do to kids is I like to say, they say, how old are you? And I say, I'm 5. And then I'm not lying, because I'm telling them in decades. And then the kids usually walk away confused. And then that's the thing. So then, you know, that's my point, is that you need to really report a unit. Now, here's what we do when we convert something by something else. We need to make sure we cancel the units that we're converting out of and into the units that we want. And now you have to come up with the relationship between those two. And it is 1 foot equals 12 inches. And that's called a conversion factor. And you know what? You are not changing the measured number that is 145 inches. You're just changing how you express it. But then you just go and, without, you know, daydreaming or anything, you go and you just, and without thinking too hard either, you go put 12 next to inches, and you go put 1 next to foot. And then you get your handy dandy $10 calculator, or whatever kind of calculator you got. If you got a TI 472, that's great for you. And then I got 12.1 feet. We'll talk about why I made that in 3 digits next time. And so you see where I lined them up, and I even cross them out. And you know that what you really got are units of feet times inches divided by inches. But when you divide inches by inches, they cancel. Okay, so now here's what I want you to do next, and then we're going to do more of this next time. Let's say we were going to convert 4.79 nanometers to picometers, something like that. So let's say we're going to do that. Now, you don't have to, there's no one way to solve the problem. But what you could do is you could convert this to meters, and then using the multipliers, you could then, you know, say, well, okay, I know that 1 nanometer is 10 to the minus 9 meters because Mike told me, right? And I memorized it. Do you know what you also could say? You could say that there's 10 to the 9 nanometers in 1 meter. And I can convert 4.79 nanometers to meters, and then I could convert meters to picometers. I could do it in 2 steps. It doesn't matter how you do it. Or you might recognize that those are 10 to the 3 away from each other, and the picometer is 10 to the 3 smaller than a nanometer, and you just 4.79 times 10 to the minus 3 is your answer, right? And actually I got it wrong there because I tried to do it too fast, 10 to the positive 3. But what you could also do is you could say, well, 1 picometer equals 10 to the minus 12 meters. Or I could say 10 to the 12 picometers is 1 meter. Those are both saying the same thing. It's saying that a picometer is a billion times smaller than I said billion. See, that's wrong. It's trillion. times smaller. So here's what I could do though, folks. I like to line up all my units first. And then I pick whatever conversion factor above I want. I only need any of these two that would fit. So I'm going to go, okay, in my mind, I'm going to go and I'm going to convert nanometers to meters. And then after that step, I'm going to convert meters to picometers. All right? Now I'll give you I'll tell you exactly what I like to do. And this might, after you get good at this, you'll see how wonderful this is. I like to put my ones down here and my powers of 10 on top, so they just add. So I'm going to go and pick this conversion factor, and without thinking too hard, because thinking too hard is dangerous, I'm going to go and I'm going to say 10 to the minus 9 meters right there. That's what went right there. Then I'm going to take the other one where there's a 1, and I'm going to take that conversion factor, and there's my 1 meter, there's my 10 to the 12. And now look at the beautiful thing that just happened to us. My answer is 4.79 times 10 to these things add. So it's 10 to the 3. And my units are no longer nanometers, no longer meters, but picometers. And I did what they said. And it really, did you see me touch my calculator? Never. Never touched my calculator, did I? So that's the skill that is useful in unit conversion, and it's really not deep thought, folks. You got to pay attention. Make sure you don't get these backwards. If I were to, a lot of the things I see my students do, and it's something you can improve upon, they get it backwards, and to be honest with you here, you don't really have a good frame of context to say, that answer is a bunch of garbage, But a lot of times you do. You could say, that doesn't make sense. That number should have got bigger or smaller. Folks, I want you to do a bunch of unit conversions. I know you've got homework to do it in. Check out the OpenStax book or whatever your homework assignments are. But I think I've inundated you with enough today. We're going to talk more about units next time, and I'll have to remember to talk about temperature as well. We'll talk about degrees Celsius, and you'll never see a temperature in Fahrenheit. You'll see it in Celsius, or what we call Kelvin. So we will see you next time. Get that. The brain is like a muscle, folks. This is the stuff you need to exercise and get limber in your synapses. Aloha!